so can you guys see my screen now? Wait a second.
Yes, sir.
Wait lang.
Yes, sir.
Ay, ayusin lang ako. Okay. Okay, let me just share my screen again. All right. So, okay. So in here, as you guys can see, we have one module which is combined with four modules. Okay. So I mean one tab. How do you call this one? One module tab. Okay, which is composed of week 5 and 6. Well, of course, since pinagsama ko na, maraming modules na i-discuss which compose of four modules. Okay, so the module 9 up to module 12. So for today's meeting, we'll finish the module 9 and 10. So don't you guys worry. Uh, as long as you guys know the fundamentals, these two are super easy. Okay, especially that it's open notes, so you won't be having any problem in solving these two modules. Okay, so napakadali lang nila, unlike mesh analysis or Kirchhoff's law. They have their own your own unique style on how to approach things, but in here parang iisa lang. Okay, we only have one way to solve things using source transformation and then delta to y and then y to delta transformation. Okay, so as long as you have these two modules, you're good to go. Okay, all right. So as you guys can see also, we have a lot of practice exercises here. So yes, you're still going to have a quiz, okay, additional to quiz for source transformation and then delta to y. However, due to lack of time, okay, since I would like you guys to uh, spend your time to practice, okay, and then finish the remaining activities without a hassle, okay. Masyado kasi nakaka-overload kapag nagbigay pa ako ng additional 2 quiz pa, okay. Since meron na lang tayong exactly like 10 days before your hindi naman 10 days, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 days. Okay, so parang 12 days na lang, okay, finals nyo na. Okay, so we'll try to finish the two modules right now, okay, and then you guys have 12 days to finish these two quizzes. Okay, bilang pala 12 days, 15 days kasi August 5, minaximize ko yung natitirang araw. Okay, so hanggang Thursday, okay, yung exam natin. So, yeah, meron pa pala kayong 15 days before the final exam. So, I thought parang 1 week na lang exam nyo na kagad. Well, anyway, so that's also a good thing that we have a lot of free time. So, yeah, just make sure to visit those external links. So, they will help you a lot to understand more about source transformation. Bakit meron akong source? Ayan. Kasi nandito na pala ito. Source transformation and then y to delta and delta to y conversion. And then of course the Millman's theorem and then the maximum power transform theorem. Okay, which is the last module. Okay. And yeah, so those are the only things that I need to mention before we'll go with our official discussion on the module 9. So do you guys have a question so far or a clarification before we proceed to the module 9?
Wala naman po, sir.
Okay, so if you guys don't have a question anymore, then let's start. Okay, so eto kasi parang pwede ko na siyang i-explain. I'll be straight, okay? Pwede ko na siyang explain in 5 minutes. Okay? As long as you know the fundamentals, okay? Notepad. Okay, notepad tayo. Because in source transformation, the theorem that we're going to use, is Ohm's law only. Okay. Once you've mastered the Ohm's law, then you'll be able to perfect the source transformation without a problem. Okay, so this is optional. You can also use KVL. Okay, but we're going to use purely Ohm's law. You can also apply KCL. Okay, but then again, you can uh, also use Ohm's law only. Okay, so I is equal to V divided by R, or V is equal to I and then R. So KVL is used to get the voltage, and then KCL is to get the current. But in Ohm's law, we can already have that one since we have that formula, okay, in Ohm's law. So the V is equal to IR, and then I is equal to V divided by R. Okay, so let me divide the source transformation into two. So we have voltage. So since ito kasi yung laging meron tayo, voltage source, and then we also have a current source. Okay, so as it names implies, we're going to convert, okay, a voltage source into a current source or vice versa. Okay, so dito ko nang ilagay vice versa from current source into a voltage source. Okay, so let's divide those two. Okay, so here are the requirements, and then on this side are the let's say results. So from voltage source to current source muna tayo. Okay, from voltage source going to current source. Tanggalin ko na lang to. Confusing. Ayan na lang. Okay, so the requirement for you to be able to convert a voltage source into a current source is B must be, or ito na lang, isang word na lang, it must be in parallel. Mali, baliktad. It must be in series rather. Okay, it must be in series. Naman i-align. Okay, wait a second. So it must be in series going to parallel. Okay? So dapat yung voltage source nyo is in series with the resistor. So saan siya series? Series siya sa resistor mo mismo. Ayan. Okay? And then as a result, magiging parallel na yung connection nila. So later on, you will see this transformation from series to a parallel. Okay? So yun lang naman yung pinaka-requirements para ma-transform natin ang voltage source into a current source. So from here, you can already use I is equal to V divided by R. Okay? Oops. What happened? May umalis. Okay, I thought I got disconnected. So ngayon, tatlo na lang kayo. Apat pala. Wala nang pawala. Pag naging dalawa na lang kayo or isa, hindi na ako magdi-discuss. Bahala na kayo. Siyempre, nakakatamad ding mag-discuss kapag walang pumapasok. So, parang taken for granted kasi recorded naman. Tapos, panoorin ko na lang mamaya. Ganun. So, papaisip tuloy ako kung i-record ko pa ba or hindi. Well, anyway, so let me just check. Are you guys still around? Mr. Carlo, Mr.
Yes, sir. Dito
Francis,
pa po, sir.
Yes, sir.
Mr. Sajin, and then Miss Grace. So three boys and one girl. Okay, anyway. So, ngayon pala nagpapasalamat na ako. I really appreciate your presence right here now, guys. Because without you guys, hindi ako may inspired na magturo. Okay, bakit ko pa ituturo to kung hindi naman kayo interesado makinig? Okay. So, okay pa yatang mag-record na lang ako and then ibigay ko na lang sa inyo yung recorded video. Well, anyway, so yeah. We have this requirement, kahit isa lang, requirement and then result. Okay? So, we can also do the vice versa, of course, from current source to a voltage source. So, of course, just do the opposite of this one, okay? So, this one must be in parallel, okay? So, if you're going to analyze the circuit, it must be in parallel with the current source, okay? With the resistor. And then, as a result, okay, just apply VIR, and then as a result, you will have a series connection right here, okay? Then after that, because our main goal and why we are applying source transformation is to have a series connection. Okay, this one is kind of similar with the what is the theorem? Yeah, the Norton's theorem and then Thevenin's theorem. So we are solving for a specific path. Let's say we are trying to get the voltage across that path, or we are trying to get the current on that certain path. Okay, because if we have a series connection, we can easily solve things without a problem just by applying Ohm's law. All right. Anyway, so let's have this put aside for now. So we'll go back to this notepad later on. So just a little background of study. So it is an electrical network can consist of sources and passive elements. So sources could be current source or a voltage source, and then passive elements are of course the resistors, capacitors, inductors, and then passive, not passive, and yeah, so halo kasama pa yun. So those are the only passive components. And then we can divide these sources into two. Okay. So other than having a current source and then a voltage source, we can also have an independent source and a dependent source. So as its name trying to imply, independent stands alone. It doesn't depend on the other components or on the passive components. But a dependent source, okay, so the value of the voltage or current depends on the amount of current or voltage elsewhere. Okay, so meaning this one is dependent on one or two components that you have on your electrical circuit. Okay. Well, anyway, let's have a further explanation on why we have this source transformation. So knowing that, the complexity of electrical networks ranges from very simple, okay, let's say a voltage divider, into a very complicated internal structure of an integrated circuit, okay. So if you're a good analyzer, or let's say you're an expert when it comes to analyzing designs, okay, you will easily know that a good electrical designer is expected to have a sound knowledge of the entire system irrespective of its complexity. So no matter how complex it is, let's say we have a bunch of wires, a bunch of resistors, you can easily simplify that one into a super simple circuit. Okay, like for example, you have a lot of resistors, you can just add them in one single value, like applying a parallel law or a series law for the resistance. So the same with the sources. Okay, you can easily let's say convert that voltage source into a current source, and then if you have multiple sources, you can combine them as one. Okay, so that's basically the benefit of learning about voltage. I mean, uh, source transformation, the voltage to current and then current to a voltage. Okay, so with that, you will be easily identify, okay, on how to simplify this circuit, okay, no matter how complex it is. Okay, and this is also absolutely essential when the issue arises of upgrading or troubleshooting the system. Okay, so this is where the electricians will be coming from. So iniisa-is nila, i-check nila by using voltmeter or the VUM. Okay, so is this working? Do we have the voltage right here? Do we have the current right here? Okay, and so on and so forth. And then from there, you will easily or they will easily be able to identify the problem. Okay, and then of course with the help of the theorems. So dapat in-expect nila yung voltage or yung current na dumadaloy dito is something like this. Yun kasi yung parang nasolve nila according from the values of those resistors and then the voltages. But if that is not the computed value, let's say using the VOM, then there must be something wrong with the connection. Okay. So at this point, it is essential to note that analyzing an electrical circuit is sometimes easy and straightforward, taking only a couple of minutes in its entirety. Sometimes, though, it can involve a lot of hard work, okay, or rather smart work. So dito na pumapasok yung ito na kasi modern ngayon eh. Before, they are really analyzing it one by one. But right now, we just, with our technology, I saw a technology wherein they will just take a picture, okay, of that PCB or circuit board, and then that picture will be imported to a certain application, and then matara-transform na siya into a skeletal electrical circuit, like parang yung sa LT Spice nyo. Okay, so parang ganun na siya. So with that, they will easily identify the flow of current on this path, the voltage, this path, and so on and so forth. Okay, so yeah, well, of course, with the help pa rin ng theorem kung sakaling hindi ka sigurado kung gano'n ba talaga yung connection nun. Okay, so you have to verify that one, okay, using some basic rules and then some basic theorems. Okay, well, anyway, so that's it for the uh, background of study when it comes to this source transformation. So here are the list of important theorems along with a brief explanation. So sinama ko lang dito just to recall. Okay, so when say superposition theorem again, so it aids in finding the current and voltage in a circuit which has multiple sources. So Thevenin's theorem and then Norton's theorem. So this will give you a simplified circuit. So Thevenin's theorem will give you a series connection, and then Norton's theorem will give you a parallel connection. Okay, but of course, with a single resistor. So yun lang naman yung parang similarities nila. And then the rest, they differs when it comes to sources. So Thevenin's is voltage source, and then Norton's is with the use of a current source. And then Millman's theorem, so we haven't discussed this one yet, but this one is good when there's a lot of involved parallel branches. So pag marami tayong parallel connection, so we can just easily apply Millman's theorem and then find the specific value that we are looking for. Okay, so at this point, it should be noted that all these theorems are based on the basic rules governing the field of electronics, namely Ohm's law and Kirchhoff's laws. So these two are the foundations, okay, when it comes to everything, okay, or those theorems that we have just discussed. And then additional, okay, which we haven't discussed yet, okay, which will be discussed later on after this module. So we may sometimes find a circuit which has the resistors connected either in a delta or pi or star to y or t configuration. So delta or pi, they are just the same. So sometimes it's called pi, sometimes it's called delta. So the same with this one. So sometimes it's called star connection or y connection or t connection. Okay, or y configuration or T configuration. Okay, so those three are just the same, just different terminologies. Okay, so in such cases, we can employ star delta or delta to star to transformation when analyzing the circuit. So later on, I will discuss this one. So for now, wala pa siguro kayong idea what is this delta, what is this pi. But yeah, it's just a conversion. Okay, from this to this or vice versa, from this to that. Okay, anyway, so let's start now with our first example. So let's have an independent source for now. Okay, so later on we're going to have an example for the dependent source. So our goal right here is to find the current, okay, denoted by I through the central 5 ohm resistor. So we have to find the current that is flowing on this, let's see, node X or this branch right here. Okay, so as you guys can see, we cannot just simply apply Kirchhoff's law, okay, or mesh current analysis. That's because we have this current source right here, okay. Well, we can transform this one first and then apply mesh analysis or Kirchhoff's law later on. But since we're talking about purely source transformation, we are not going to use that one to simplify or to find that specific I in here. So we're going to use simply or purely, okay, source transformation. Okay, so from here, let's go back with our notes. So as you guys can see right here, we can actually transform this one right here, this 1 amp and then 10 ohms into a voltage source. So this is a current, this is a resistor. So what is the requirement again? From current to voltage. So from current to voltage, they must be in parallel. Okay, and then just simply apply V is equal to I times R. Okay, so in here, so V is equal to I times R. So I is 1 amp and then R is 10 ohms. So very easy. 1 times 10 ohms is equal to 10 volts. Okay, so yan na yun. Ganun lang kasimple. So you have already transformed, okay, one source into another source. So from here, it will become something like this. Okay, So were you guys able to follow that one? So take note, from parallel, it became a series connection. So it's now in series with our resistor. So did you guys get that one so far? Hello, hello, hello. Hello? Anybody there? So isa pa lang to ah. First step pa lang to. Marami pa tayong step. Baka akala nyo ito na yung last or yung pinaka-end. Hello? Are you guys still around?
Yes, sir.
Okay. Were you guys able to get this one, and how did we arrive from this, okay, from this parallel connection into this series connection? Hello, nakasunod ba kayo?
Yes, sir.
Imposibleng hindi. Nag-apply lang tayo ng V is equal to I times R. Yan lang yun. Okay? So, from here, okay, one thing that you will notice is you have to decide, okay, the polarity of your voltage source. So, is it right here or right here? So, that one will depend on the flow or the arrow where it's pointing the current, okay, or the arrow that's pointing. So if it's going to left, then the left side will be your positive sign. Okay, and then the tail is of course the negative side. So ganun lang siya. Okay. Then after that, you can now simplify this one a little bit more. So again, our goal is to arrive with a series connection. So dapat ganito lang siya. Into one source, and then let's say you can have another resistor right here and then another resistor. So that's our goal on this circuit right here. So from here, we can arrive with this kind of circuit. So how did we arrive with this one? So we just simply added the resistors. So 10 ohms plus 5 ohms is 15 ohms. And nothing happened on the left side since wala namang ibang resistor dun. And then from here, you can arrange this one into something like this. Okay, so we have the 10 volts right here. And then napunta na rin dito yung 5 ohms. So the same on the right side. So nandito na yung nandito rin yung nandito pa rin yung resistor natin. But our voltage source right here is move in here. So with that, we can easily identify again which source we can transform into another source. Okay. So from here, as you guys can see, we have a series connection. Okay. And then we have a series connection. So our uh, rule again when it comes to transforming a voltage into a current, they must be in series. Okay, so voltage source, so they must be in series, and then the result will become a parallel. So how will we get the current? So just apply Ohm's law. I is equal to V divided by R. I is equal to V divided by R. So in here, our voltage is 10. Okay, so sa left side muna tayo. And then our resistance is 5 ohms. So 10 divided by 5. Tama ba? Yeah, 10 divided by 5 is of course equal to 2 ampere. Okay, so this is the left side area, but what about the right side? So let's do the same. So 10 volts for the voltage and then 15 for the resistance. 10 divided by 15 is equal to 1/3. 2/3. Okay, or I think this one is 0 point something. Where is my calculator? Divided by 3 is equal to 0 0.6667 or 0 0.67 ampere. Okay, so after transforming that one, of course, this series connection, okay, will become a parallel connection. So ito na sila. Okay, we have 2 amps right here, and then we have the 2/3 amp right here, or the 0.67. Okay, and then from here, okay, here's a good thing when it comes to a current. So as you guys can see, we can easily add a current, okay, as long as they are in the same direction. So one thing that you will notice, our left side current is flowing from here to there, and then it will eventually flow on this node right here. Okay, and then this current will flow right here, and then it will eventually flow on this node right here. So as you guys can see, they will merge as one current. So 2 amps plus 2/3 is equal to 2.67 ampere. So we could say that it is now, okay, our current source right here, okay, which is 2.67 ampere. Okay, and then another thing, we can actually add already those three, but since we wanted to get the specific current that is flowing in here, okay, we have to combine only the 5 ohms and then the 15 ohms. Okay, and then as you guys can see, they are in parallel, so just apply the rules of parallel. So it will become, okay, so ano kaya ang pangalan nito? Well, anyway, so R na lang, pangalanan na siyang R. So it will become a 5 times 15 divided by 5 plus 15. So 5 times 15 is 75 divided by 20. So this one now is equal to 3.75. Tama ba? 15 times 5 is 75. Yeah. Divided by 20 is 3.75. So it will give us a result of 3.75 ohms. Okay, for those combined resistor. So nandito pa rin of course yung resistor natin. Okay, so it's still in parallel connection. We just simply combine those two. So this will give us a result of 3.75 ohms. And then the 5 ohms will stay right here. Okay. And as you guys can see, we have to apply one more source transformation since our goal is to have a series connection. Okay, so let's go back with our notes. So from here, we applied a parallel connection with those 5 ohms and then 15 ohms. And then you will get this one, the same with what I have. 15 divided by 4 is 3.75. And then the current right here is 8 out of 3 or equal to 2.67 amps. Okay, so in here we're just using the uh, fraction. Okay, but in here I'm using the decimal uh, type of a number. Okay, and then from here we can apply again source transformation from current source to voltage source. So just simply use V is equal to I times R. So after that, you will have this computation. So V is equal to I, which is 8/3, and then times resistance, which is 15 divided by 4. Then after multiplying that one, it will give us the result of 10 volts, which is now this one. And then of course, from parallel, it will become a series connection. Okay, and then from here, you can now just simply uh, add those two, 15 divided by 4 plus 5 will give you the total resistance, and then eventually get the total current, which will give us the same result as 8 over 7 ampere. Okay, so in here, I'm just showing that you can also apply KVL if you want, but you know, to make it simple, you can also apply Ohm's law only. Okay, so since they are in series, you can just add them and then get the total current, and then whatever is the current that you will get, that's already the final answer. Okay, so I will not explain the KVL part anymore since it's already in here. You can just go back in here and then analyze this one again. But just to show you guys the Ohm's law formula, since I mentioned a while ago that we're going to purely use Ohm's law. So the RT for this one is equal to 15 divided by 4 plus 5. 15 divided by 4 plus 5 will give us a result of 8.75. Okay, and then of course in getting the current, it's I equal to V divided by R. So V is equal to 10 divided by R, which is 8.75. So this will give us the result of hmm, bakit iba ang sagot? Ay, tama. Okay, so it's 8 out of 7 or 1.14. Okay, or 1.14 amps. Okay, which is the same with this one right here, the 8 over 7. Okay, so we now have solved the current that is flowing on this branch right here. So are we clear with this one? Are you guys able to follow?
Yes, sir. Nagets na po.
Yes, sir.
See? So napakadali lang nito. Ohms law lang and then you're good to go. As long as you know this rule right here. So screenshot nyo na lang to. Then okay na kayo sa source transformation. Sobrang dali lang nito. Okay, so we still have 2 minutes left. So let's try to maximize our time. So we have another example, but right now we're going to deal with a dependent source. Okay, so let's dive into the circuit right away. So again, I will leave the reading part to you guys. So in here, our goal again is the same. We have to arrive at this the same series connection. Okay, so how do we do that? So by simply applying source transformation. Okay, so in here, as you guys can see, we can actually split this one into two since they are in series connection. So if it's in series, as we all know, we have only one current that is flowing on that path. So we can do this kind of circuit right here. So we have 3 amps that is flowing on this 1 ohm and then 3 amps which is flowing on this 2 ohms right here. Okay, but since we have node in here, it's like they are now in a parallel connection. That is also due to this source right here. Okay, but anyway, so yeah, we can transform this one into this kind of circuit. So time check, 1 minute left. So we'll just continue the rest on the part 2. So goodbye for now and then see you guys later. Okay,
Yes, sir.
so yeah.